morning! Good morning. No, wait, hold on. It's the afternoon. Sorry. Good afternoon! All right. For all of you that have been wondering where the January 2019 Regents, Algebra 2 Regents is, I am really sorry. Really sorry. Since January, I've been in the process of moving my house. My new apartment is, I'm renting a house. It's because my new house isn't ready, and it's just a not new house. Whatever, who cares? It's new to me. Anyway, this is the January 2019 Algebra 2 Regents Exam. My name is Mr. Krause, but you can call me, and I'll work on my penmanship, but you all know if you watch my videos, my penmanship's not great. Just listen to me. I like to talk. This is going to be part 1 through 12. Ooh, 12. By the way, if you ever want to find this stuff, the easiest way to find this stuff is just to type in www.mrkrausemath.com. Go over here and click on Algebra 2 Regents, and then go down here to Algebra 2 Regents. And I believe I have all the way up through August done now. And I am working on these January ones now. They should be up, well, hopefully they're up now. All right, kiddos, let's get started. Let's rock and roll. During this video, by the way, I am going to do a lot of drinking of coffee. By the way, it's Dunkin' Donuts coffee. It's just my mugs are in storage, so this is my son's mug. I borrowed his. All right, I'm going to be showing you how to do the problem correctly, how to look for some tricks and some traps, and how to use your calculator to maximize your score. All that stuff's going to be done in this video. If you don't like it, I'm sorry. If you like it, great. If I talk too much, I don't care. All right, here we go. Two sets of data, test scores, are the same mean but different standard deviations. In other words, you know, if you're looking at your normal distribution curve, right, they look like zits. They have the same mean, but one of their standard deviations is greater than the other one. So if we call this R1 and we call this R2, right? R2 is greater than R1. So let's make R2 like 10 and let's make R1 like 2. Okay. So if I was looking at R2 spread, or R1 spread, I would go down 2, which would go to, let's say my mean was 30. I'd go down 2 to 28 and up 2 to 32. Well, on R2, I would go down 10 to 20 and up 10 to 40. So this is, by it having a greater standard deviation, and again, I haven't looked at the answers in a while, but I'm going to guess they're going to talk about spread, because remember, standard deviations measure spread. The larger the standard deviation, the more spread out the data. The smaller the standard deviation, the more compact the data. So, data 1 has greater variability. Not true. Data 2 does. Data 2 has greater variability. There's our answer. Ding, 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 winner. But let's check the other answers just to make sure. By the way, did we look for the word false? Right? New York State likes to work in the word false in there all the time. Or not true, or incorrect, or untrue, or not untrue, or they do. The variability will be the same for each data set. Nope. No conclusion. So definitely number 2. Simple problem. There it is. Bodied up. Number 2, if f of x equals the log base 3 of x, and g of x is this image of f of x after a translation 5 units to the left, which equation? Now, look, left and right translations occur in parentheses. Up and down translations occur outside the parentheses. So, outside the parentheses, up and down. Inside the parentheses, right and left, but we have to remember it is backwards. Now, I'm going to tell you right now, this calculator can be, this problem can be done just using a calculator, but I'm going to show you how we do it first. 5 units to the left. Now, that means it's to the left, so we're going to put it inside the parentheses, but instead of going minus, which would be left, we're going to go plus. So this is the right answer, choice 1. Now, I'm going to show you and check my answers because, quite frankly, I make a ton of mistakes. Let's see what we got here. I'm going to graph the original. The original was log base 3 of x. So control log base 3 of x. There it is. And I want to make sure that that goes to the left 5 units. So I'm going to press tab. And I'm going to do control log base 3 of x plus 5. Now, if that goes to the left 5, I'm good. Now, watch it. Cha-ching! There it is. All right, choice 1. All right, let's see what we got here. When factoring to reveal the roots of the equation, which expression can be used? So I showed you how to use the calculator on this one. So I'm always going to show you the mathematical way to do these first. And then I'm going to, quite frankly, tell you that you probably shouldn't be doing this one this way. And I'll show you a real calculator trick. Dunkin' Donuts from RPI. Can't beat now. It's just Dunkin' Donuts from downstairs. Anytime we have a polynomial, please don't call me up and say, there's no such thing as a polynomial. I get it. It's a polynomial with 4 terms. I just like to call them polynomials. It sounds cool. You group it. So out of these first 2, I can take out an x2. Oh, x2, x squared. Sound like a fool. And then I put x plus 2. And then out of these 2, I can take out a 9, but because I have to copy over whatever sign this is, I have to copy it over. It's really taking out a negative 9, and I'm left with x plus 2. Now, that's this one. So anything with 1 in it has to stay. You got to go. So now I got to check 2 or 3. Now, if I factored this, it would be x plus 2 times x squared minus 9. So that makes this one not right. So anything with 3 in it's got to go. Oh, there's my answer. Now, where does that answer come from, you say? Well, take a look at this right here. This is it in factored form. What if I was to do this? What if I was to say, okay, we're going to take this x and we're going to multiply both of those. That would be x times x squared minus 9. And then I'm going to copy over the sign plus 2. And I'm going to multiply that times this, x squared minus 9. And that's where this one comes into play. So both x and 2. But day of the Regents, don't do it that way. Watch the way, watch how this gets done. Now, does this take a little time? Yes. Is this a great check? Yes. Follow along. You're going to input any number you want for x, but don't choose 1 or 0. And I always tell my students, pick something stupid. There you go, 2.35. And store that into x. And then I'm going to type in the original problem. The original problem was x cubed plus 2x squared minus 9x plus 18. Shabam, there it is. Oh, minus 18. So you got to put it in right. All right, so that's just a dumb answer. Negative 15, so blah, 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 blah. Who knows? So now I'm going to put in choice 1. X squared. Oh, not W. X squared, parenthesis, x plus 2, parenthesis, parenthesis, minus 9, parenthesis, x plus 2. Now, if this is correct, it should be the same exact value. Oh, God, it's the same exact value. That's crazy. I drink some coffee. Then I'm going to put in the second one, which was x times x squared minus 9 plus 2 times x squared minus 9. And hopefully this is the same thing. Oops. Oh, yeah. So there's a weird thing about this calculator. Do you see this right here? It does not like this. X parenthesis. Anytime you do multiplication that's implied, which means I didn't put a time sign in there, I just left out that time sign, sometimes you get errors on the calculator. So go back and put them in. Ah, there we go. Look at that. Same exact answer. Now I'm going to put the last one in, which was x minus 2, parenthesis, x squared minus 9. And you'll see that that's not the same, so therefore that's the answer. All right, kiddos, 3 questions done. I'll be right back. I like to save every once in a while, and I get some more coffee. All right, kiddos, we got a ball bouncing. Here's our ball. Oops, I got the eraser. Here's our ball. All right, when the ball bounces, the heights of consecutive bounces are a geometric sequence. Whenever they say geometric sequence, that means we're going to multiply. And we're probably going to want to use this geometric sequence formula, which just got hidden, which I don't know what I did with. Right here, that geometric sequence formula. But we'll come back to that in a second. The height of the first bounce is 121 centimeters. So it goes down, and it bounces back 121 centimeters. The height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the fifth bounce? Ooh, man. All right, so this is not going to work this time. We're really going to have to use this geometric sequence. So here's how we're going to do it. Here's the simplest way to do it. I'm going to show you. We can do it a couple of different ways. So my first bounce was 121. I don't know what it was my second, but my third bounce was 64. Now I want you to notice something about those. Those are perfect squares. And that's because we're going to end up taking the square root of something. All right? So how do we work on a geometric sequence? Well, a geometric sequence says we can take and we have to multiply by some number. We'll call it x to get to this, whatever this number is here. Then I'm going to take this number and multiply it by x to get this number. So in other words, I'm taking 121 and I'm going to multiply by x, and then I'm going to multiply by x, which is really just x squared, and I want that to equal 64. So I divide by 121, and I get x squared equals 64 over 121. Now, again, I go back to the significance of those perfect squares now, right? If I take the square root of both sides, first of all, normally when we take the square root, we put a plus or minus. However, this is dealing with the heights of balls, and negatives don't make any sense. So we won't even worry about the negative. It's definitely going to be positive. And the square root of 64 is 8, and the square root of 121 is 11. So this is our common ratio, 8 over 11. Okay? All right. So how am I going to figure out what the fifth bounce is? Well, the easiest way to do this is to come over here to the old calculator, clear out all this crap, and we'll say, okay, put in 121, and we're going to multiply by parentheses. Well, actually, you know what the easiest way to do is just press. I'm going to show you a way to do this. Now I'll just do this way. Times 11 divided by, nope, can't do it that way. Times control division. 11 divided by 8. I'm going to put a decimal in there. Enter. So that's the second bounce. Then I'm going to take that and multiply it by control division. 11 over 8. Now this should be 64. That's weird. That's weird. It should be 64. I wonder why. So I'm going to come back over here and I go, oh, it's 8 over 11. Well, that was just plain stupid. 8 over 11. And then I'm going to take that and I'm going to multiply by, times control division 8 over 11 and press enter. And then I'm going to take that. Now, this is a pain in the neck. So let me show you a real quick way to do recursion or geometric sequences. Then I'll show you another thing to do. I could just do this, 121, enter, and then I can hit times control division 8 over 11, and I put the decimal in just so the calculator gives me the decimal answer, and I press enter. There's 88, there's 64, that's 1, 2, 3, here's 4, and here's 5, 33.8. So the fifth bounce is, so a sub 5 equals 33.8, which is approximately 34. Now, I could have also done it this way. I could have used that geometric sequence formula, which says a sub n equals a sub 1 r to the n minus 1. Now, remember, a sub 1 is your first term. Boom, there it is. R was this value that you had to find. You still have to find this r value. And then I can just come over to my calculator and say, okay, I want the fifth term. So I'm going to take 5 and I'm going to store it into n. And then I'm going to type in 121 parentheses 8 divided by 11 decimal raised to the n minus 1. Now, you could have just put 4 in there if you wanted to. And there you go, 33.8. So there's a couple of different ways to show you how to do the problem. All right. Well, let's see how we do this problem. So I'm going to look at this quadratic formula. I'm going to tell you one of the common mistakes made that we saw when we were grading these, and we look back and we're like, that should have been an easy problem, is this right here. Do you see this thing right here? Lots of kids forgot about this. Now, quite frankly, I don't think we should be doing this. If it's multiple choice, use the calculator as much as possible. But here's what I'm going to show you. I'm going to show you like a couple of different calculator tricks. But the first thing we got to do is move that 9 over. Otherwise, we're going to get all messed up. So we're going to get 5x squared minus 2x plus 4 equals 0. Now, because all these are crazy answers, I know I'm going to have to use the quadratic formula. But the way this quadratic formula is written is really, really, really annoying. And that's because never ever will you see an answer where you have one big long fraction over 2a or whatever. So what we often do is just break it up. We're going to put 2a here, and then we do plus or minus, and then this part of the fraction. And if you look at all these answers, isn't that what they have here? Small part, plus or minus, all over. So that's what we're going to do. So we're going to write that formula down, but we're going to write it down split up. So negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now this part right here, that part's called the discriminant. If the discriminant is negative, you're going to see i's. If the discriminant is not negative, no i's. So we're going to have to find that. And I always have my kids do that work off to the side because that way it doesn't mess up the work that we're doing over there. So we're going to write this down, A, B, C, D. D standing for discriminant, A, B, C, and then the discriminant, capital D. A is 5, B is negative 2, C is not 13, it is 4. Now, D is b squared minus 4ac. Please don't write negative 2 squared. Negative 2 squared is always positive, and b squared is always positive. So 4 minus 4 times 5 times 4. So what is that? 4 minus 80. So I believe this is negative 76. All right, so I got negative 76 there, so I'm ready to type in. Oh, wait, it's negative. That means I know my answer is going to have an I in it. So let me get rid of the two answers that don't have I in it so I don't make that silly mistake. All right, now let's start writing. X equals, negative b is 2 over 2a, which is 10. That's 1/5. Oh, these are both 1/5. That's not going to help us out at all. Plus or minus the square root of, I need to put negative 76 in there, but the first thing I'm going to do is pull out this I, because I know this negative just gives me an I. And then 76, you know what, I'm going to work on that one. So I'm going to show you guys a little cool trick on your calculator that you may not know about. If you don't know this or I do it too fast, rewind, check it out, okay? What I'm going to do is I'm going to put a set of numbers in. And I'm going to do control right parenthesis. And then I'm going to do 2, 3, 4, 5, 6, 7, 8, 9. Oops. Or maybe 10. And then what I'm going to do with this whole set of numbers, at one big time, I'm just going to square the whole thing. And now that's the set of all squares. Now here's the really cool part. I'm going to take that number 76, and I'm going to divide by that entire list all at once. And I need to find out which perfect square goes into 76. Oh, there's only one. 4 goes into 76 19 times. So now I already know the answer. There's the answer, because it's 19. Because this is really 4 times 19. Now, what is the square root of 4? It's 2. So now I have 2 over 10, which is 1/5, plus or minus, and again, 2 over 10, which is 1/5, or I square roots of 19 over 5. Now, that's one way to do the problem. Let me show you another way to do the problem. I'm going to show you another way to do the problem. And that is using your calculator. I'm going to show you two more ways to do the problem. The first one is menu. It's menu, go into calculator mode. Menu 331. It's not the same on this one. So menu algebra, polytools, and find the roots of a polynomial. Second degree, but you always got to change this to complex because that'll give you the imaginary answers. So the numbers were 5, can't put that in there, -2, and 4. Now, mine will give it to you like this. Yours will probably give you the answers more like this. Let me just, your calculator, if you do it on your calculator, will give you more probably answers like this. And you see how that's imaginary? So here's your 0.2, which is 1/5. Then you just got to figure out what that's equal to. Well, if I take the square root of, 19 and divide it by 5, which is that one answer, I get, oops, again, my calculator will give me the exact answer. If I want the decimal, I put a dot. 0.87111, there's that way. That's one way to do it. That's kind of hard, a little weird. Let's do it this way. We're going to start with the answers. So the answer was control division, 1/5. Now you can't do plus or minus, just pick one. Control division, the square root of 19 over 5. I. Now I is down here in the pi button. We'll click on that I. And we're going to take this and we're going to store this into X. So it looks really funky. You're like, whatever, whatever, whatever. But then you're going to go, okay, now I'm not going to type in the changed one. I want to go back and I want to type in this. If that equals 9, I know I have the right answer. Always go back and check in the original. So 5x squared minus 2x plus 13. Don't hit equals. Do not hit equals, because every once in a while the equals is going to say false, even though it's true. Just hit enter, and there it is, 9. We're done. Problem's over with. Sometimes the equals doesn't work. Done. Problem. Woohoo! All right, I'll pause. I'll be right back. All right, this problem. I don't know about other math teachers. If you're another math teacher and you hate these problems, give me a shout out and say, hey, I hate those stupid problems too. But this problem, it comes up every year. And every year, whoever the writer is for the Regents exam tries to make it even more and more and more complicated. This one's not too bad. I'm going to show you how to get by this question on the Regents, even though, whatever. So the thing is, this is called modeling an equation the different way, or some standard like that, changing the way the equation's modeled. So here's the original. Y equals 2,000. 1.04, there's your 4% growth, raised to the t. So if I want this monthly, here's what they do. Here's what they're going to do. They're going to say, okay, 2,000, 1.04 to the 1/12 to the 12t. What? Where did that come from? Well, they're just rewriting the way the equation looks so you can see what it is monthly, and you can see your monthly interest rate. This would be our monthly growth interest rate, which is this percentage right here, or this percentage right here. It's actually one of these is 2 is the answer. It's actually, this is the answer. But what do I do with exponents raised to exponents? Don't I just multiply those? Yeah. So if I was to grab my calculator and just do 1.04 raised to the 1 divided by 12, I would get that crazy decimal inside there. And there you go. And then it's to the 12t, because the 1/12 and the 12th, if they cancel them, if I multiply 1/12 times 12, don't they just cancel each other out? I'm back to the original. Now, how can I do this and make sure 100% that I'm right on the day of the Regents? Well, here's the easiest way. Come back to your calculator and say, you know what? I want to go 2.5 years, or 2.54687 years. It doesn't matter what choice year you pick. Pick something obnoxious, and we're going to save that into t. And then we're going to type in the original, which was 2,000, 1.04 raised to the t. And you get some value. And then I'm going to type in the answers, and I'm not going to type them all in. I'll type the first one in. 166.67 parenthesis 1.04. I don't even know where they get these crazy answers from. 0.12t. Enter. Well, that's not the same. Remember, again, we're looking for this 2210. And then the answer is this, parentheses 1.00. Now, it's not going to be exact, but it's going to be really close. 32737. 32737 raised to the 12t. 2210.096, 2210.098. There you go. There's the right answer. Bodied, problem's over with. Yeah, that's right. Cool people say bodied. And so do I. Question 7. Tides are a periodic rate. Rise and fall with the ocean. On a typical day at Seaport, to predict the time of the next high tide, the most important value to have would be the periodic. Doesn't that make the periods? Where do I see periods? Raise the tide, lower the tide, raise the tide, lower the tide, raise the tide, right? This is a sine or cosine curve. It's a sinusoidal curve, sine or cosine curve. Right? Right? So if I wanted to predict the time from the top to the bottom, from high tide to low tide, then I want to figure out what? Well, the question says it's periodic, right? And what does periodic stand for? Periodic stands for, what does the period stand for in a sine or cosine curve? That's the time to complete one full curve. So if I was doing this sine curve here, this would be the period. Time it takes to finish one full curve. That's one full sine curve. Well, if I knew that, then wouldn't this be the distance between the top and the bottom? Wouldn't that just be half of the period? In other words, half of the time it takes to finish one full curve. Or I could say, I could also do this. If I knew the time, let me do this, the time it takes to go from one low curve all the way to back to one full curve right here, from low curve to low curve, hopefully that's not behind my big bald head, from low, if I knew that time, well then wouldn't half of that be from low tide to high tide? And that's why this is the answer. Time between tide heights is 20 feet. Nah, that's useless. The average depth of water, that's useless. And the difference between the water heights at low and high tide. No, because that's not going to tell us about time. That just tells us about height. So 1 is the answer. An estimate of the number of milligrams of medication in the bloodstream T hours after a 400 milligram has been taken can be modeled by this. What time interval does the amount of medication in the bloodstream strictly increase? Well, there is zero way to do this problem except to graph it. So we got to graph this sucker. And I'm going to pause it while I throw this thing. Oops, that's not what I want. I'm going to pause it while I throw this thing into my graphing calculator so I'm not wasting your time. Because I'm just going to go into graphing calculator and you'll see in a second that that's filled in. Okay, I got this I got this typed in, and I double-checked to make sure it's correct. But I haven't hit enter yet because I think something weird's going to happen. Yeah, it's kind of hard to see what's going on here, right? So what I want to do is I want to change this. Now, I think the graph said it was a 400 milligram thing, so I don't know what I want to change this to, but since it said 400 milligrams, I might overshoot and go 600. And 10 should be good. I can see what's going on now, right? I can see what's going on here. All right, so I want to know, it says in the problem, well, for what time interval does the amount of medication in the bloodstream strictly increase? Now, if the graph of this thing looks like this, strictly increase would be from here to here, or from here to here, right? Those would be strictly increase. Here, this part, or here, this part, not this part. That's decreasing. So all I got to do is figure out if it's going, is it increasing from 0 to 2? So here's what we're going to do. I'm going to go menu, trace, graph trace. It's probably the easiest way, and I just keep hitting right. Oh, look, there's about 2. See how it's 2.1 down here? So from 0 to 2, it kept going up. But how about if I go over to 3? Nope. See, 3's on the downward slide, so not 3. How about from 2 to 6? So this is 2 over here. So it's increasing. Now it's decreasing, down to 6. How about from 3 to 6? Well, from 3 to 6, here's 3 to 6, it's going down. So the answer, the only time it's increasing is choice 1, from 0 to 2. That's a pretty straightforward question. Which representation of a quadratic has imaginary roots? Now, imaginary roots means for graphic does not touch x-axis. So this one does not have imaginary roots. Its roots right there. For on the table, I'm looking for 0 for y values. So here's a root and here's a root. So that has imaginary roots. They're trying to trick you by not putting a 0 in the x column. It doesn't have a y-intercept, but it has 2 roots. So now what I'm going to do, it's down to one of these two. I know this is the answer because this is a parabola that opens up and it starts at 32. But I'm going to show you what it looks like. So we're going to go to this first one. I'm going to get rid of this. And it's 2 parentheses. And before I even hit the graph button, you should know what this looks like. Squared. And then, oops, here, I got to bring this 64 over. So if I bring this 64 over, what I get is minus 64 equals 0. So minus 64. Now, before I graph this, this is what's called vertex form. The vertex is -3, -64. Remember, when we come in and out of parentheses, it's backwards. And then this moves down 64 units. So that's a parabola that's opening up that moved 64 units down. So you're going to see that, yeah, that hits the x-axis. It hits the x-axis here, and it hits the x-axis over here. So that does not have imaginary roots. So this is the final answer. Tab 2x squared plus 32. You're not going to be able to see it until you change this to like 50. And there it is. So do you see how it doesn't hit the x-axis? Therefore, it has imaginary roots. Good? All right, let's move on. Got to stop at 12. Some more Dunkin' Donuts courtesy of my RPI mug. That's my son's. All right, so one of these questions, they're pretty simple. A random sample of 100 people that would best estimate the proportion of all registered voters. Remember, we're trying to eliminate bias. Now, bias is things like response bias, asking people questions that might make them feel nervous and change their answers. Bias might be going to just one location and getting all the same kinds of people, so on and so forth. So this one is talking about people that would want improvements of the high school football field. So, should I ask people at a football game? No, because those are all crazy parents and kids that want better sports things. So they're all going to say, yeah, we should have the best football ever. Just like that. So no. People at the supermarket. Okay, everybody has to go eat, right? So everybody has to go to the supermarket. So you're going to get old, you're going to get young, you're going to get middle-aged, you're going to get all kinds of people there. So that looks like a pretty good mix of people. Let's see if it's the best. At a school fundraiser. No, if you go to the school fundraiser, you're only going to get people that kids are probably in school. You don't get the elder generation, and you get the younger generation that doesn't have kids in that school. At a high school band concert. No, because if you're at a high school band concert, all the band parents are going, oh, but what about band? What about music? What about chorus? What about the music? Why is money always going to the sports? And the sports people going, oh, why does the money always go to the band and the orchestra? So, you're going to get those parents. So the clear mix of people that's best, old, young, middle, got kids, don't have kids, everybody's got to eat. Supermarket. Perfect answer. All right. Here's another one that can be done strictly using the calculator. But I'm going to show you the right way to do it because that's what I'm here to do. So see how this is squared? That means I got to write this twice. I'm going to show you the right way, and then I'm going to show you a really quick trick on how to do this using your calculator. Now you're all thinking, you can't do that. Yes, you can. And I will show you. But please follow along because they love to ask these questions as a part 2 questions. So you got to be on your game and you got to be able to do this if it's a part 2 question as well. Now, anytime you get to a problem that has I in it, I will tell you right now, the one thing you better remember is this. And it's this simple, simple fact that I squared equals -1. It will come into play on this problem and any problem that looks like that. And we are multiplying by -1 almost every single time. So you'll see in a second where that comes into play. So I'm going to take this 2x, I'm going to multiply by both of these. So I get 4x squared minus 2xi. Now I'm going to take this -I and multiply by both. So minus 2xi plus, because -I times -I is positive I squared. Now this negative right here is what I like to call bad. You fill in the blank. It's bad. You got to remember it's there. So I'm going to keep these things in parentheses because that negative is god awful. If you don't take into consideration that negative right there, zero shot of getting this right unless you cheat using the calculator trick I'm going to show you in a few minutes. But you're going to use the calculator trick anyway to check your answer because you only want to check your answers, right? Sure. Thank you, Mr. Krause. You are not weird. So now what we are going to do is we are going to multiply this 2x by both of these. So I get 4x squared and plus 6xi. And now the -I times both. Minus 2xi minus 3i squared. So I'm going to do a few things. I'm going to clean this up. So we get 4x squared minus 4xi minus 1. Because remember, this right here is -1, so minus 1. So I'm going to keep cleaning this up. Oh, no, that's all I got for that. Minus 4x squared. These two combined give me plus 4xi. Now, we got to be careful. We got minus 3 times -1, so that's plus 3. Now is where this negative, this bad, I got to say it, this badass negative. That is a badass negative. Because now you got to distribute it. It becomes -4x squared, -4xi, and -3. All right, so here comes the fun part. This 4x squared cancels with, oh, this should have been a squared. It cancels with this 4x squared. This -4xi and this -4xi make -8xi. And this -1 and this -3 make -4. Now that was a ton of work to get this answer right here, which is choice 1. I believe I got that right. Now I say I believe I got that right. I'm not even 100% sure. I got down there, I'm like, okay, I got one of the answers. Woohoo! Now was it one of the answers I got because it's one of the answers they expect me to get if I do something stupid? Or is it the right answer? So again, why not check your answer? So here's how it's going to work. So please follow along. This is a great way to do this problem. As a matter of fact, if you're taking the Regents exam, I would just do it this way. Remember, nobody looks at your work on part 1s. It's a bubble sheet. It goes in the computer, or it goes into the system, and BOCES spits back a grade to all of us. And we're like, woohoo! Well, there's the grade. I don't know how they did in the multiple choice. So here's how you're going to do it. You're going to take 3.25478.9. Really doesn't matter. We're going to store that into x. You can pick any obnoxious number you want. Just don't pick a very big number. Just pick a decimal like 3 point something, 4 point something, something kind of small. And then we're going to type in the original. Now the original was 2x minus, now you got to use the I button, I squared, minus, the badass minus, and then 2x minus, got to use the I button, I, times 2x plus 3, got to use the I button, I. Now, you're going to get some ridiculously dumb, stupid-looking answer. There it is. 0.4 minus 26 point blah, 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 I. Doesn't matter. We came up with this answer, negative 8xi minus 4. So we want to make sure that's right. Negative 8xi minus 4. Now, if that turns out to be the exact same stupid decimal as that, we know we got it right. So all of this work that I did here, all of this work that I did here, yes? Did I really have to do it? I could have done it just using the calculator. All right, last thing. Suppose events A and B are independent. Which of the statement could be true? Okay, so we're looking for the true statement. So what we got? Oh, let me just think about this for a second. Dependent. So if I got independent, that means this. The probability of A is equal to the probability of A given B. Or the probability of B is equal to the probability of B given A. In other words, we don't care that this happened. Probability of A is still the probability of A, but B happened. The probability of B is still the probability of B, but A happened. We don't care. So that's two of the independent. So as soon as you see this word independent, you're going to write these three things down. Oh, 3, there's one more. Let me get that third one down for you. And this is probably the most useful, and that is the probability of A and B is equal to the probability of A times the probability of B. Now, this comes into play all the time. I don't know if it's this one, but we're going to find out. So we got to figure out which one of these crazy things is true. So we know that the probability of A and B equals 0.2. So let's take a look at this first one. This first one has an or in it. Oh, do you remember the or formula? If you see an or, you got to write the or formula. So that's the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, now I just start plugging stuff in. The probability of A or B is 0.5. Does that equal 0.4 plus 0.3 minus 0.2? Well, let's see. That's 0.5, and that's 0.7 minus 0.2. That looks like that works. Did I do something stupid? Okay, so that equals 0.5, right? There's the right answer, correct? There we go. Woohoo! Except for one thing. And this was a very tricky question. I almost fell for it, but I didn't. And I did when I go back, and I forgot I had to do this. So this is crazy. So this question makes you think you got the right answer because it worked in the OR formula, correct? Except for one thing. They told you that the probability of A and B is equal to 0.2. If I take these two things together and multiply them, where's my calculator? Oops. And I do 0.4 times 0.3, I don't get 0.2. So that's not the right answer. Although that was really tricky. We're going to get rid of that one right now. So then we're going to check this one. Let me give myself some room. The next one says that the probability of A, so the probability of A is 0.8, and the probability of B is 0.25. And we already know the probability of A and B is equal to 0.2. Well, if I take 0.8 and multiply it by 0.25, I get 0.2 equals 0.2. And there's the right answer. But boy, oh boy, New York State, that was not nice. Hey, kids, if you haven't hit subscribe, hit subscribe. If you haven't hit the like button, hit the like button. If you didn't like it, hit the like button anyway, because I would really appreciate it. Hopefully I helped you out. Keep drinking Dunkin' Donuts coffee. They're one of the sponsors. Not. I have no sponsors. You're my sponsors. Let your friends know. Keep studying. Keep working hard. You're going to crush this New York State Regents exam. It doesn't take that much to pass. You all can pass. Just keep working hard. All right. Good luck on the exam, kids. Goodbye.